Welcome to Module 2 of Big Data Analytics. In this module, we will explore the Hadoop ecosystem and its core components. You will understand why Hadoop emerged as a solution for big data, how it differs from traditional RDBMS, and how it processes and manages massive data efficiently. Introducing Hadoop. Hadoop is an open-source framework developed for storing and processing large-scale data across distributed systems. It allows organizations to handle structured, semi-structured, and unstructured data efficiently. Why Hadoop? With the explosion of big data, traditional systems struggled to manage volume, velocity, and variety. Hadoop solves this by storing huge data reliably, processing data in parallel across clusters, offering fault tolerance and scalability. Why not RDBMS? Relational databases are designed for structured data and limited scalability. They face challenges when data grows beyond terabytes, schema becomes inflexible, processing needs parallelization. Thus, RDBMS cannot handle modern big data workloads effectively. Difference between RDBMS and Hadoop data type. RDBMS structured, Hadoop any type. Scalability. RDBMS vertical scaling, Hadoop horizontal scaling. Cost. RDBMS expensive hardware, Hadoop commodity hardware. Fault tolerance. RDBMS limited, Hadoop built-in replication. History of Hadoop. Hadoop originated from work at Yahoo, inspired by Google's file system GFS and MapReduce papers. Doug Cutting and Mike Caffarella created Hadoop in 2006. Over time, it became the backbone of big data processing. Hadoop overview. Hadoop consists of 1. HDFS, storage layer. 2. MapReduce, processing layer. 3. Yarn, resource management layer. Together, they form the foundation of the Hadoop ecosystem. PIN, use cases of Hadoop, social media analytics, fraud detection, recommendation systems, genomic data processing, log analysis. HDFS, Hadoop Distributed File System. HDFS stores large files by breaking them into blocks and distributing across cluster nodes. It provides high throughput, replication for fault tolerance, scalability with commodity hardware. Processing data with Hadoop. Hadoop processes data in parallel using MapReduce, ensuring tasks are distributed and executed closer to where the data resides. Managing resources with Yarn. Yarn, which stands for Yet Another Resource Negotiator, separates resource management from processing. It enables multiple applications to run on Hadoop clusters by scheduling resources, managing cluster workloads, improving efficiency. Introduction to MapReduce programming. MapReduce is a programming model for parallel processing. It works in two main phases. 1. Map phase divides input into key value pairs. 2. Reduce phase aggregates intermediate results into final output. Components of MapReduce. Mapper takes input and produces intermediate key value pairs. Reducer combines and summarizes mapped data. Combiner, an optional mini-reducer for optimization. Partitioner distributes keys across reducers for load balancing. Searching, sorting, and compression. Searching. Hadoop can filter large data sets efficiently. Sorting. Keys are automatically sorted before reaching the reducer. Compression. Reduces storage space and speeds up data transfer between nodes. Conclusion. To summarize, Hadoop revolutionized the way big data is stored and processed. With HDFS for storage, Yarn for resource management, and MapReduce for parallel computation, it provides a complete ecosystem for big data analytics. That wraps up Module 2, Hadoop and MapReduce. If you found this helpful, don't forget to like, share, and subscribe